Okay, we are given 3 the square root of 2 minus 2 the square root of 7 divided by 2 the square root of 7 minus 7 the square root of 2. I forgot to check one thing, if the videos from last week are completely deleted. I need to check that. 1 second, I'll show you. Uh-oh. Because if they're not, they may impede my current video. Okay, perfect. Sorry about that. I should have taken care of it earlier. Okay, so in this problem, we are asked to rationalize the denominator. So remember, this is like a minus b. Obviously, we have to have a plus b, and top and bottom have to be the same. And then after we multiply, we will multiply this and put it here as a squared minus, we'll multiply this and put it here and as b squared. So what will be the conjugate of the denominator for this situation? What do you think? Yes? Square root of 7? Exactly. Plus 7 the square root of 2 to the square root of 7 plus 7 the square root of 2 indeed. Now the numerator requires more work, so I'm not going to have enough room here, so I'm just going to continue with the next row. So let's determine the denominator first. We want to square this. When I square 2 the square root of 7, first I square 2, what do I get?
4.
Times the square root of 7, which is, that's it, minus 7 squared, 49, and the square root of 2 squared. Excellent. The next step, I have to FOIL the top. Slowly, let's do this together. First, I multiply the outside. 3 times 2. What is that? Perfect. Times the square root of 2 times the square root of 7. What do I get?
Square root of 14.
Excellent. Now I'm moving on to the second term with the last one. First, the outside. 3, the outside. So 3 and 7. The square root of 2 times the square root of 2. Right. You're correct. The square root of 4, but I would like to simplify. Perfect. So we distribute the first term to the last two. Now I'm here. Negative 2 times negative 2 times positive 2. Perfect. Square root of 7 times the square root of 7. Excellent. Negative 2 times positive 7. Perfect. Last thing here that we need to multiply, last two quantities, the square root of 7 times the square root of 2, which is the square root of
14.
They are real numbers. We are allowed to multiply them. Perfect. So now I have to combine like terms. I know that 21 times 2 is 42, and I know that 4 times 7 is 28. So 42 minus 28 is 14. Now we have 6 the square root of 14 minus 14 the square root of 14. It's like 6 apples minus 14 apples. They are like terms? Yes, negative 8 the square root of 14. Excellent. Now the denominator. So 4 times 7, we have 28. But remember, the denominator will be now 49 times 2, which is minus 98. For some reason, I thought it was a complex number. I said, oh, this should be positive. But no, but it's not. We don't have complex numbers. Okay, so the denominator will be negative 70. Would you agree?
Yes.
Now we have no choice, but we have to separate it. Negative 14 over 70 and plus 8, the square root of 14 over 70. Because we need to present it as a complex number, the real part plus imaginary. And yes, we have to simplify it fully. So I see that 14 and 70, I can simplify by 14 actually, right? So it's negative 1/5. 8 and the 70 I can only simplify by 2. So I have 4 the square root of 14 divided by 35, and this is it. And we rationalize the denominator of this expression. Although this was from the previous test, correct?
It's from the,
But the previous test.
from the homework.
Yeah, but from the previous test. This new test coming up is not going to cover that. Yeah. Okay, so let's take a look now at x plus 4. We have another question. Raised to 1/2 plus 9 equals 5. Is that it? Was there something else, Bob?
That's it.
Okay, perfect. So what type of equation is it? And how do we start? What is the starting point? Without knowing what it is, I may have difficulties in solving it. When we see power 1/2, what does that power bring to mind? When we see a power 1/2, what does it mean? What about power 1/3? We have to discuss this. This is very important. So forget about this for a moment. When I see, let's say, x to 1/3, or x to 1/2, or x to 2/3, what brings to mind something like this immediately? What do you think? It's okay if you're wrong. I just want to know what you're thinking about. What are all these? Radicals. They're all radicals. Every time you see a fractional exponent, or an exponent that is a fraction, or a rational exponent if you want, you always have to think of radicals. Always. So the first one, x to 1/3, will be what?
Cube root of x.
Perfect. The next one, x to 1/2, will be? Right. And what about x to 2/3? What will that be? Oops, I didn't mean to put a comma there. It's the yes of
X squared.
that's it.
Or the cube root of x quantity squared, everything squared.
If you want.
Sometimes
Yes.
I find it easier to think of it that way.
Sometimes, yeah, I agree. Okay. So now finally let's go back to our equation. I see a power 1/2. What type of equation is this then? What type? Of course, it's a radical equation. Is there another way of writing it? I'm going to copy it because I have something else in there now. So x plus 4, everything to 1/2 plus 9 equals 5. So we identify that it's a radical equation. Perfect. So now tell me how to write this. Is there another way of writing it? Yes? How? Excellent. Good. Equals? Good. Perfect. Negative 9 plus 5. And now I'll say, wait a minute. Remember what we said about the square root. The square root has two major issues. Two. The quantity under the square root has to be positive or 0, and the answer has to be positive or 0. Let's look at the graph of the square root, of any square root. I mean the base function. Domain 0 to infinity, range 0 to infinity. This is always a positive number unless it has minus in front. If it has minus in front, it's a negative number. But this is a positive number that I'm telling you equals a negative number. Will you be able to ever find a real number that makes a positive equal a negative? No. Let's say we have not noticed that. We don't know that. We just didn't pay attention and we didn't see that. So how do I solve this equation then?
Square both sides.
Excellent. Let's assume that we decide to square both sides. We get x plus 4 equals 16. Therefore, x equals good. Now the question is, remember we used a principle that is not 100% type of principle. I can square both sides, but I may get solutions that do not belong where in this equation that I'm solving. They may not solve that. It may not work. So now it's part of the problem to go back and check. So I'm going to go back and check. How much is 12 plus 4? 16. How much is the square root of 16? 4. Very good. How much is 4 plus 9? Is that 5? I'll say absolutely not. No solutions, which we could have written from the very beginning. A positive number cannot equal a negative number. The square root of x plus 4 looks like this. This is the square root of x plus 4. Here is y equals negative 4. This is the square root of x plus 4. Where does this portion meet this graph? Where does this graph meet this graph? It doesn't. They don't, right? So that's why no solutions, because a positive number cannot equal a negative number. The graph of x plus 4 is this graph, and the graph of y equals negative 4 is here. They never overlap. They never have a common point where both sides are the same. So I'll say immediately, hey, no solutions. There's nothing there.
So as a good practice, it's always good to go back and check the answer.
It's part of the problem.
Right.
So when we square, if you tell me add 5 to both sides of this equation, that's fine. I don't have to go back and check. I know it's a legitimate operation. So if I have 1 pound here and 1 pound here, and you say add 2 pounds on both sides, I'm not going to go back and check solutions because it's true. I have no doubt that if I started with 1 pound equal 1 pound, and I have added 2 pounds on both sides, I did not destroy the balance. But if you say, and the same thing with subtracting, then you say subtract 1 from both sides, fine. Then you say multiply both sides by 2, fine. You say divide both sides by 2, fine. But if you say square both sides, then I'll have to say, wait a minute. If I square both sides, I may not, or may not get an equation that has the same solutions with the original one.
So,
Squaring both sides, we have no choice, but it's not a 100% legitimate operation. We start with this equation, the next one may not have the same solutions with the one we are solving.
so is it true to say in general you won't have this problem with odd indexes?
Absolutely true. Absolutely true.
But you
Why?
will.
Because the cube root, as an example, the cube root is defined everywhere. And the answer is anything. But when we square or take to the 4th power, we may change a positive into a negative. And we may change a negative into a positive. And then anything can happen. But when we cube both sides, the sign is preserved. If this is negative and this is negative, when we cube them, they stay the same. If this is positive and this is negative, whatever, when we cube them, the sign will not change. But when we square, the sign will change. So when I started that, if you remember, I gave you an example that was silly. This is a silly example because when I start with the equation x equals 2, first of all, it's already solved. Secondly, why would I square? It makes no sense. But I said, bear with me and let's square both sides. And here's what happens. This equation has two solutions. But I started with x equals 2. This one is okay, but this one is not, because negative 2 does not equal 2. So, of course, the only point I'm making here is not because I'm teaching you how to solve x equals 2 by squaring both sides. I'm only saying that if at any point in time you have to square both sides, it's possible that you get solutions that do not work in the original problem. Therefore, checking solutions back in the original problem is part of the solution. It's absolutely mandatory. Does it make sense? When I was taught this a very long time ago, we didn't do that. We stated the domain. So, some people say that this is easier. In a way, I agree. It's fine. So it's part of the problem to go back and check. Now, if you state a domain, right? So if you state a domain of this function, you will write x plus 4 greater than or equal to 0, which means x greater than or equal to negative 4. Right? So that will be your domain. So when you plug in x equals 12, well, right? So when you square and you get x equals 12, then you will say, well, indeed, 12 is greater than or equal to negative 4, but you're not really checking the other side. So you have to be careful. So I'm in agreement with this, saying that, yeah, I think we should disregard the domain, we should solve the equation, and go back and check. It's a safe way of solving radical equations. Very good questions, Bob. Anything else? Anything else, or we start the review? And I would like to go back to what we have to review. Let me also write this down for you. We have to review 1, 2, 3, 4, 5, 6, 7, 8 homeworks. Okay, so it's 30, it's 32, it's 34, it's 36, it's 38, it's 40, 42, and 44. 8 homeworks. You have double of that. So you have double because it's learning and then practice, and then learning and then practice, right? So I would like us to just go to these 8. So hopefully we can do all of them today and review again on Wednesday, or whatever we can do today. So I'm clicking on 30. So the practice, the algebra of functions. So let's take a look. And let's choose from here. So it's an 18 question assignment. So find the domain of this function, okay? So here is our first question. What will you write? Because remember, why do we need to look at the domain? Is because when we add, subtract, multiply, divide functions, they have to have a common domain, right? If there is no common domain, then we have nothing to talk about. Okay, so in this case, this is a function at the top, which is 10x, and the function at the denominator. So we created a function, it's a ratio. What do I have to write in order to find the domain of this function? And we've done this with rational equations. So this should not be a problem here.
Well, the first thing I see when I look at that, if I see x not equal 11.
That's it. There is no other restriction. So I'm going to copy it here. So the function is 18x divided by x minus 11. Indeed, x cannot be 11. So when we write a domain of this function is negative 11, negative infinity to 11 union 11 to infinity. There is no need for that plus. That's the domain of this function. Okay, moving on. We're not going to be able to look at everything. So if they repeat, we're going to continue. Okay, same thing. Can anyone just give us the condition for this one? X does not equal? What? Which number? Which one? What do you think? It's okay. Just tell me what you think. Of course. So the domain is negative infinity to 7, union or 7 to infinity. Good. Okay, what about this one? How many values you must exclude from the domain? You will exclude negative 8 and 2. So I exclude negative 8 and I exclude 2 right here. Is that okay? Yes? Is it clear how we write the domain? Okay, so maybe I should write this function here for you in the notes. So that was f of x, 3 over x plus 8 plus 6 over x minus 2. X cannot equal negative 8 and cannot equal 2. Therefore, the domain is negative infinity, negative 8, union. Union is the replacement of the conjunction or. So negative 8 to 2, union 2 to infinity. This is or. Okay, moving on. Please stop me if you have questions. Okay. Okay, here we're given two functions. Let me check the next one. Yeah, same thing. Okay. Okay, which one would you like to work on? So same thing, we're given, in the previous example, we're given two functions and we're asked to find the sum. In the next one, we're given two functions and we're asked to find the sum, the difference, the product, and the ratio. So let's go with this one because we have everything in there. So f of x equals 11x, g of x, negative 2x minus 6, and we want to find the sum, difference, product, and ratio. Of course, the question will also ask you to find the common domain, because remember, I may be asked to find the sum, the difference, the product, and the ratio, but if they don't have a common domain, I won't be able to find those. So what is the common domain? What is the domain of function f? Indeed. Domain, all real numbers. What is the domain of function g? Domain. Negative infinity to infinity, it's a polynomial function. All polynomials, linear function, quadratic, cubic, polynomial. Remember we wrote that last time, polynomial functions, and before, sometime, I'm not sure whether it was exactly last time, but before, when we talked about algebra functions also. Polynomial functions are defined on all real numbers. So since the common domain, they are defined on the same thing, right? So then the common domain is negative infinity to infinity. This will always be the domain of the sum, domain of the sum, domain of the difference, and domain of the product. You don't have to write that again. Once you write the common domain, you know it's the domain of those three. We cannot guarantee the ratio though. There is no guarantee there. So I can find these three functions, and after I find this one, from the common domain, I will remove the values of x that make the denominator 0, if they exist. If the denominator could be 0, I don't know. We'll see in a moment. Okay. So then f plus g of x, by definition, is f of x plus g of x, and I have to write this. I copy f of x, which is 11x. I copy g of x, which is negative 2x minus 6. The reason I put parentheses is because I can have plus and minus without being separated. So this is 11x minus 2x minus 6. In other words, 9x minus 6. Any questions? In the same way I find the difference. I copy f of x minus g of x. I copy f of x as 11x minus, in parentheses, negative 2x minus 6, and I just perform the operations, changing the signs. So this is 13x plus 6.
You have to change the sign.
Because I distribute, I have no choice. I'm asked to subtract. That's why I wrote this first, so I can see the division, the subtraction symbol, or the difference, and then I have no choice. Here, distributing positive 1 will not change the signs, but here distributing negative 1 will change all the signs to the opposite. Is that okay? Clear? Okay. So then FG, I write a definition so I don't make an error. I have 11x and in parentheses negative 2x minus 6. And now I have to distribute because it's multiplication. So I have negative 22x squared and plus 66x. Not plus, but minus, sorry. I'm distributing positive, so they both stay negative, of course. Okay, now the ratio. F over g of x. By definition, it's f of x over g of x. I copy 11x and I copy negative 2x minus 6. Okay, now what? Now, like before with the previous examples from the homework that we just looked at, we have to state the domain of this. What is the restriction? What do I have to write? I will have to write that what? Give it a shot. Quickly, because I have to put my tent out now. Sun is coming. I don't know, why do these not prevent the sun rays to go through? I don't understand. Okay, I'm ready. Say it again. But I have to write the negative 2x minus 6 cannot be 0. I'm not sure how we got negative 2, right? The denominator cannot be 0, right? So when we move negative 6 and divide by negative 2, we get x cannot be negative 3. Okay, perfect. So then what is the domain of the ratio? Just the ratio, not the other ones. Can anyone dictate the domain of the ratio?
The first part would be from minus infinity to minus 3.
Yes, indeed. Negative infinity to negative 3, union negative 3 to infinity. So you see there is no bracket. I cannot use a bracket because if I use a bracket, it's included. I have to use parentheses, which means it's not. Any questions on this? Any questions? Okay, I think we're okay with this. So for the pair of functions f and g, determine the domain of f plus g. What is the domain of f?
5.
Anything but. Excellent. Anything but positive 5. Awesome. What is the domain of g? Anything but negative 3. So it's everything but negative 3. Good. So then what would be the common domain then? If I want to add, subtract, multiply, or divide them. What would be the common domain? This one has everything but 5. This one has everything but negative 3. What would be the common domain? The idea is like this. You have in your pocket everything but 5, and I have in my pocket everything but negative 3. What do we have in common? We don't have 5, and we don't have negative 3. You have negative 3, but I don't, right? I have 5, but you don't have 5. So then what would be the common domain? Everything but? Exactly. Here it is. Everything but negative 3 and 5 as we discussed. Perfect. Okay. Determine the sum. Same thing. Okay. So let's find for these two functions, let's find f of 3 plus g of 3. So I'm copying f of x, x squared minus 6x, and g of x is 6 plus x, and they want us to find f of 3 plus g of 3. We have two options. One option, what is this really? This is nothing else but f plus g of 3, because f plus g of 3 is f of 3 plus g of 3. So one option would be, which I recommend, find f plus g, which is f of x plus g of x. F of x is x squared minus 6x plus, no parentheses are needed. So this is x squared and minus 5x plus 6. And then in f plus g, plug in 3. 9 minus 15 plus 6. So that's 15 minus 15 is 0. The other option is to simply find f of 3. F of 3. So f of 3 plus g of 3. F of 3 will be 9 minus 18. And then plus g of 3 will be 6 plus 3. And we have to get the same answer. And we do. Because this is 9, this is 9, this is negative 18, so this is 0. We have to get the same thing. It's up to you. You can say, but this is much easier. That's fine. One or the other. However, the answers must be the same. Okay, so this was 11. Pretty much the same idea with the difference. Same idea with the product. Stop if you say, okay, I want to see this. Same thing with the ratio. We create a ratio and then we plug in 2. Same thing, the ratio and plug in negative 2. Find the domain of the sum. Same thing, they're all real numbers, so it's all real numbers. We just looked at an example like that. Find the domain of f over g. We just looked at an example like that. Okay, let's look at this one. This is our last problem here. The bar graphs show the population of a particular country in millions for 5 selected years: 85, 90, 95, 2000, and 2005. X is the number of years after 1985. M of x is given, f of x is given. Answer the following questions. Write a function that models the ratio of males to females of a particular country for the years shown. So we want the ratio of males to females. So m of x, a function for males, f of x, a function for females, but we want the ratio. So what are we creating then? We're creating a new function, which is m over f of x. So let me just write that for you. M over f of x. This is the function we create. And in this case, well, in this case we have m of x over f of x, and that would be 1.96 x plus 117.4 divided by 1.79x plus 148.8. Okay? So this is the algebra of functions. Finding the common domain, finding the sum, difference, product, and ratio, finding the domain of the ratio, which is not the common domain. It could be, but not necessarily. So that was 14.3. Okay, so this was the algebra function. Let's move on to composition and inverses. Oh, let me check on my video. Oh, it's still okay. Okay, here we have the composition and inverses. So we're given two functions. We're asked to find the composition, f cum g, g cum f, and f cum g of 2. So I would like you to say, I want to see this example or that example. Well, let's see what else. Same thing. 2 examples the same. Same thing. 3 examples the same. I would like to go with the third one though. 4th example the same. So 3 or 4, 5, So these are all the same. Now this is a different story. So please choose from the first 5 problems that you would like to work on right this moment. Okay, so I will choose this one. Okay, so we have f of x equals x squared plus 3, and g of x equals x squared minus 3. We're asked to find f cum g of x, g cum f of x, and also f cum g of 2. Okay. Remember, when we talk about function composition, we're not worried about the common domain. If they have a common domain, fine. If they don't, fine too. It doesn't matter. Okay, so by definition, this is f of g of x. So I have to write f, and in parentheses g, and I copy g. So let's take a look. F says whatever squared plus 3. How do I write that?
X squared minus 3 squared, minus squared.
Yes, awesome. So I have to write x squared minus 3 squared, and then
Plus 3.
plus 3. Good. So now when I square a binomial, please think for a moment. We have an agreement, sort of, that we signed a long time ago. When I square a binomial, what do I have to write? How many terms? Yes, awesome. Thank you. Thank you. Good. The first term squared, what do I write? X squared squared. It's x to the 4th power. Copy the base, multiply the exponents. Minus 2 times the first times the second. 2 times 3, 6. 6x squared, and plus 9. Plus 9 plus 3 is plus 12. This is a new function that was determined by the composite of f and g. G being the inner or the outer function. F being the inner or the outer. Which of these two functions is the inner? The one that is applied first to x.
6x plus 2, 6x squared.
So I have f and inside g. So my question is, which one is the inner function? The function that we apply to g first, to x first.
Plus 12.
The function that we apply to x first is g. G is the inner function. That's the first replacement. So we applied, this is the inner, and this is the outer. So first to x, I apply g, replacing it by x squared minus 3. Then I apply the function f to this new number, and that's how we get the result. Is that clear? Good. Now, what about this? G of f of x, in other words, or g of f of x, right? Can anyone tell us which one is the inner function now? The one that we apply to x first. The inner function is? Indeed. F of x is the inner function. So g of x squared plus 3. And now we look at g. G says whatever squared minus 3. So what do I write?
x squared plus 3 quantity squared, and then minus 3, I think it is.
Excellent. So when I square x squared minus 3, how many terms do I get? Excellent. The first term squared, copy the base, multiply the exponents, plus 2 times 3 times x squared, plus 3 squared, which is 9, and 9 minus 3, which is 6. Now we're asked to find f cum g of 2. But I have f cum g, it's right here. So in order to find f cum g of 2, I will plug it in. 2 to the 4th power minus 6 times 2 squared and plus 12. 2 to the 4th is 16. 2 squared is 4. 6 times 4, 24, and plus 12. 16 plus 12 is 28. 28 minus 24 is 4. And we answer all parts. So f cum g, we determine to be x to the 4th minus 6x squared plus 12. G cum f, we determine to be x to the 4th plus 6x squared plus 6. And then f cum g of 2 is 4. So that is function composition, an example. Now we're given two functions, and we're asked to show whether they are inverses of each other. Any two functions, there is more than one example. I see already 3. So let's choose from these 3 to show whether they are inverses of each other or not. Would you like to choose, or I will?
Number 6.
This one? Or you said number 6, the previous one. Okay, very good. So we have f of x equals 8x plus 7, and we have g of x equals x minus 7 over 8. So we're asked to find whether these two functions are inverses of each other. So what do I have to determine? And what should the answer be in case they are inverses of each other?
Well, I guess there's 2 ways you can look at it. You can plug in numbers and see if you get the reverse of the other one.
Right. However, that's not recommended. Because that a proof by example is not really a proof. So it has to work for all numbers, and you will not be able to show that it works for all numbers.
You have to use the analytical process.
Yes, that's a very good answer. Excellent, Bob. Thank you. So what I have to determine is f comp g, and I have to determine g comp f, and only if both equal what? I say f and g are inverses of each other. Okay, so that's my silly example from last time. You have X dollars in your pocket. I'm giving you 5, and 2 minutes later I'll say, I want it back. How much is left in your pocket? One more time. You have X dollars. We don't count them. We don't know what we have. You have X. I'm giving you $5, and I'm taking it back in 5 minutes. Or, second possibility, I'm asking you to give me $5, and 2 minutes later I say, hey, here's back. Here's your money back. So what happened? If I took 5 and I give you 5, or I gave you 5 and I took it back, what is left? Exactly. Because giving you 5 and taking 5 back are inverses of each other. So only when the answer is plain X, then we conclude these functions must be inverses of each other. So then let's do that. I have to determine f cum g. Which one is the inner function? Which one is the function that I apply first?
G.
Yes. So this is f of g of x. Very good. Which is f of x minus 7 over 8. F is the outer function. But let's see what f is telling us to do. F says 8 times plus 7. So please tell me how to write that. So I have to copy 8. I have to copy the argument right now, and then plus 7. Is that clear? So this says f of whatever, but f says 8 times whatever plus 7. 8 times whatever plus 7. Is that clear? So obviously I will simplify first by 8. I get x minus 7 plus 7. I will combine like terms, and I get x. What do we conclude? What is our conclusion? Are they or they're not inverses of each other?
They are.
They are. However, I still have to show the other one.
Why do you have to show the other one now?
Very good question. Excellent question. The reason we have to show the other one is that in algebra, there are different types of algebras. In the algebra we work in, there should not be a need to show the other one. But in other algebras, both sides may not be the same. But here they are. So you have, just for practice, but if you show on the test and say, I guarantee that the other one is also x, I cannot argue with that. It's true. So if one direction is x, the other direction will be x as well. But let's, as a practice, let's also determine the other one. So G comp F. So you have full green light to say, I got this, the other one must be x. Because I can't say, no, you're true, it's correct, you're correct. But let's, for the sake of the argument, let's determine the other one. Which one is the inner function now? Perfect. So this is 8x plus 7. So now let's look at G. Here's G. G says G of whatever you want is whatever you want minus 7 over 8. But this is what I want. So how do I write the answer?
Eight times half of that.
So now this piece is this. So I have to have 8x plus 7 minus 7 over 8. G of whatever is whatever minus 7 over 8. But this is the whatever now. This is what replaces x. So 8x plus 7 minus 7, these two go away, nice. 8x over 8, nice, x, as expected. So I give you full permission to say, I got this x, this should be true also. However, if you make an error here and you get x, you will catch your mistake if you do the other one. So it's up to you. Pluses and minuses, like for any situation. Okay, so let's go back to this. So we know how to show where the two functions are inverses of each other. We determine the function composition and see if we get x. If we get x, they are inverses of each other. If we don't, then they're not. If the first one, if you show that f comma g is 5x, should you waste your time with the other one? No, of course not. If the first one is not x, the second one cannot be x. Okay, so now here we are asked, in different examples, we are asked to find the inverse function. So please choose an example. This is one. This is the other. This is a linear function. This is a rational function. We're asked to show, they're telling us it's inverse. They are inverses of each other. I'm sorry, they are one-to-one. So therefore, they have an inverse function. So let's find the inverse function. So which one? The other one? The previous one? Very good. So 3x plus 1. So let's work on that. So f of x equals 3x plus 1. Is this one-to-one? By the horizontal line test, it's 1 to 1 because it's a line, right? It's a line with a positive slope. By the horizontal line test, this will be 1 to 1. Okay, perfect. So first step, we replace f of x by y. In step 2, we swap. And what do we do in step 3? In step 3, we solve for y. We subtract x, so we subtract 1, and we divide by 3. So in step 4, we replace y by the notation f inverse. So please remember, this is a notation. It cannot be read and it will not be read as f raised to negative 1 of x. No, this is f inverse. F inverse. My 10 fell off the table. Okay, next one. So we found the inverse function of a 1-to-1 function. Okay. Determine whether the given graphs represent a function that has an inverse function. Does this function have an inverse function? No, because by the horizontal line test, it is not 1-to-1. Good. Next one. Is this function 1-to-1? No, because by the horizontal line test, it's not 1-to-1. It hits more than 1 point. The horizontal line hits the graph in more than 1 point. Okay, does this function have an inverse? The answer is yes, if it is 1-to-1. Is it 1-to-1?
Yes.
Of course, by the horizontal line test, is 1-to-1. It will have an inverse function. Okay, use the graph to, okay, so I'm given a graph of a line. Is it 1-to-1? Is a line 1-to-1? By the horizontal line test, a line is 1-to-1. We just determined the inverse function for a line, for an equation of a line. So it is 1-to-1. It will have an inverse function. We should, I'm not sure if they allow that to here. I'm not sure, to tell the truth. If you can graph, I would normally graph the y equals x, mandatory, and then I will simply reverse these points. So this point is 3, 0, and now I will graph 0, 3. Okay. I didn't mean to cancel the whole thing. Oh, oops. Okay, just for this. No, it's not doing it. Oh, it's probably I have to graph this first and then click on that. I see. Okay. Okay. Good. Now I have to unclick this, I think. Because I don't want the other one to be... Yeah, I don't want that. So, oh, I see. Okay. Excellent. So I had 3, 0, so it's 0, 3. I had negative 6, 0, so it's 0, negative. It was 0, negative 6. I have 0, 6. And this is the graph. So the purple or pink line is the function. The blue line is the inverse. I'm checking again. So 3, 0, 0, 3, correct. 0, negative 6, negative 6, 0, correct. And at 6, 6, both of them cross the y equals x. So then I click enter or save first, and then check my answer, and that's it. Sorry, that's not correct. Okay. I thought I checked all the points. Apparently I didn't. Oh, they want this point as well. Okay. So this point is at -1. I forgot to put that point. They wanted all 3 points. There is no need. I'm not going to ask you for 3 points. 2 points are more than enough. I mean, they're exactly what we need. So this is -1, -8. So I want -8, -1. So now I want to put one more point, which is this. And okay. And now it's going to say that's not correct because I moved this point here. Let's see. Okay. Everything is correct. It's just that I don't know how to put 3 points. So how do we put 3 points? How do you... Okay, maybe it's asking me for that point. So 8, 9, 10. Okay. This point, this point, this point, this point. How many points does it want? Okay, I don't know. Everything is correct. Everything is correct. So as you see, this is my answer, this is your answer. Okay, this is correct answer. Okay, let's check. -6, 6, 6, 6. Yes, I do have that point. I have 3, 0, 0, 3. Of course, I have that point. -0, -6. I have -6, 0. Of course, I have that point. The only thing is I don't know how to put this point as the third one.
I think it doesn't like the y equals x line.
But it has to be there. It has to be there. So I'll remove it, but it has to be there. So please remember on the paper you have to put it in. You have to graph y equals x. Every time, you're right, that's the answer, but it's incorrect. So every time we graph the function and the inverse on the same coordinate system, we have to graph y equals x. Because it shows that we are reflecting the graph with respect to y equals x. And that's exactly what we're doing. And that is the correct answer, no matter what they say. Okay. So use the graph of f to draw the graph of its inverse. Again, this is incorrect, any of these, because they do not show y equals x. All these are incorrect. So in order to graph the inverse function, yes, I will have to reflect this. It's at 0, -2. So, oh, it doesn't allow me to graph. Okay, I just have to choose. Okay, so 0, -2, so it has to go through this point of -2, 0. And this point is -6, -5, -4.5. Goes to the other side at, so 2, -5. It goes to -4.5, -4.52. So it has to go through this point and this point. Okay, so let's see. Wrong, potential, yes, yes. This is the only one. So let's take a look. So this point is at 0, -2. This one must be a -2, 0. This point is at 2, -4.5. It has to be at -4.52. Obviously, this is the correct answer, and we're done.
And the lines cross at y equals x.
But it's incorrect. Yes, but it's incorrect. So the graph should have y equals x. And they have to cross, yes. So y equals x,
Right there,
yes, right here, this point, yes. 0, 0, -1, -1, this point, -2, -2, -3, -3. So this must be there.
So the software has like a glitch in it.
Probably a mathematician didn't look at it or didn't say, hey, look. Or maybe they could not graph two functions, right? You have your given f of x. Maybe the system cannot absorb that, cannot take 2 more graphs. As the system is only looking for 1 graph. Once you put in 2, it says, oh, it's wrong. But all points were correct. I was just adding the correct sequence. Okay. Okay, so let's see. We have two more identical. So please choose. Let's take a look. Either this or this. Doesn't matter. F of g of -1 or f come g of -1. Which one?